Evaluate the definite integral from 1 to 3 ln x dx. So it's a definite integral, so we'll get some number for our answer. What can we do here? Well, we know how to find definite integrals. Thanks to the fundamental theorem of calculus, all we need to do is get an antiderivative for ln and evaluate it at both 3 and 1 and take the difference. That's it. That's all we need to do. So really, for definite integrals, I always set them aside and say I need an antiderivative first. Okay, now I don't have to worry about any of the numbers. Now maybe you remember, okay, antiderivative for ln x is x ln x minus x plus any constant, but in this case we don't really care about the constants. Okay, so if you remember that, that's great. You're off to the races, we're done. But suppose we didn't know that. Okay, let's pretend we didn't know that. What would we actually do? Well, we'd have to use integration by parts to integrate ln x. Okay, so here's what we're going to do. We're going to rewrite it as 1 times ln x. Okay, and we're going to pick for our dv this 1 times dx. Okay, that means v will be x, and whatever's left over, in this case ln, will be our u, and our du by dx would then be 1 over x, and we can just say du is 1 over x dx. So now we get to make the big switch, so it'll be u times v, so x ln x, minus v times du. But the x and the 1 over x cancel each other out. So we're just integrating 1, but we know how to do that because it's a nice polynomial. And there we arrive at something that many of you already knew, but there we go, just in case we forgot it. We remember that sneaky 1 trick, and integration by parts are how we integrate not just ln, but any logarithmic function. Okay, that's great. So when it comes to our definite integral, let's just use x ln x minus x. So x ln x minus x, evaluated at 3, evaluated at 1. 3 ln 3 minus 3. 1 ln 1 minus 1. Now ln 1 is 0, so we can ignore that. Okay, 3 ln 3, you could rewrite that as ln 27 if you really wanted to. I know a lot of people like having ln, and they don't like multiples of lns, but it really depends on your style, whether or not you want to do that using logarithm properties. Make the 3 sort of hop up here, and make it ln of 3 cubed. I'll do that just for fun. So ln 27 minus 3, and then minus 1 is plus 1. So there's our final answer, ln 27, which I guess we will write a little nicer and neater. Ln 27 minus 2. Whatever that value is. If you got a calculator, I suppose you could write out the decimals, but we always prefer exact answers in math, so that's how we're going to leave it.